Hello everyone, hope you saw my previous videos. If you missed it by any chance, the link is in the description box. In this video, we will solve 3 example problems given in the book. This is from Class 9 Science Textbook NCERT, Chapter 7, Motion. First we will go through the sum. This sum is in page number 81 of the book and example 7.5. The sum reads, a train starting from rest attains a velocity of 72 km per hour in 5 minutes. Assuming that the acceleration is uniform, find the acceleration and the distance travelled by the train for attaining this velocity. As usual, we will write down the information given in the question. First one is the initial velocity. Initial velocity u is 0. So how do we get this? It says the train is starting from rest. When it's starting from rest, we have the initial velocity to be 0 meters per second. So the next one is the final velocity v, which is 72 kilometer per hour, and the time is given to be 5 minutes. So this 72 meters per kilometer per hour, we have to convert it into meters per second. So how do we do that? 72, this kilometer has to be converted into meters, so we multiply by 1000. Then the hour has to be converted into seconds. So we have 3600. So this works out to be 72 into 5 by 18. So this is 20 meters per second. So this time has to be converted into seconds. So we have it as 5 into 60, which is 300 seconds. So the question now we have is, we have to find the acceleration. So acceleration is given to be v minus u upon t. So the final velocity v is 20 minus 0 by 300. So what do we have? 20 by 300, which works out to be 1 by 15 meter per second square. So this is the acceleration of the train. So the next thing we have to find out is the distance travelled. So this, to find this, we have the formula 2as is equal to v square minus u square. So from here we have to find s, which is v square minus u square by 2a. So v square is 20 square minus 0 by 2 into 1 by 15, which we just found out. So we have 400 into 15 by 2, which is 200 into 15. So we have 3000 meters. So this 3000 meters is equal to 3 kilometer. So we have the answer for both the questions. The first question is the acceleration of the train, which is 1 by 15 meter per second square, and the second one is the distance travelled by the train for attaining this velocity, which is 3 kilometers. So we will go into the next sum. This sum is in page number 82, example 7.6. The sum reads, a car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. Calculate the acceleration and the distance covered by the car in that time. So we have the similar question as we did in example 7.5. What is the difference here is, we have a initial velocity u. Here u is 18 km per hour and v is 36 km per hour, and time is also given. So what do we have? U is equal to 18 kilometer per hour. V is equal to 36 kilometer per hour and the time is 5 seconds. So again we have to convert this into meter per second, which is 18 into 5 by 18, which is 5 meter per second, and this is 36 into 5 by 18, which is 10 meter per second. So we have V, U, V and T. So what we have to find out is acceleration. Again the same formula, V minus U by T, which is 10 minus 5 by 5, which is 5 by 5, 1 meter per second square. So this is our acceleration. Next we have to find out the distance. So again the same formula, 2as is equal to v square minus u square. From here we have to find s. S is equal to v square minus u square by 2a. So your v square will be 10 square minus 5 square by 2 into 1. So we have 100 minus 25 by 2. So what do we have? 75 by 2, which is 37.5 meters. So the distance covered by the car to attain this final velocity is 37.5 meters. So we will go to the third problem. This problem is in page number 82, example 7.7. So the question reads, the brakes applied to a car produce an acceleration of 6 meter per second square in the opposite direction to the motion. If the car takes 2 seconds to stop after the application of brakes, calculate the distance it travels during this time. So we have the acceleration of the car. So this acceleration is minus 6 meters per second square. Why do we write this minus 6? Because it is applied in the opposite direction to the motion. When we apply a acceleration in the opposite direction, it means we are trying to stop the car. We are applying brakes. So it can also be called as deceleration. When it is deceleration, we have it as minus. The sign, we have a minus sign given to the acceleration. So this is minus 6. So next what do we have is time. The time the car takes to stop after application of the brakes is 2 seconds. From this we have to find out the distance it travels during this time. So we have two ways of finding this distance. First thing, we will find out the initial velocity, because the final velocity v is 0 because it is getting stopped. So we will find the initial velocity from the formula v is equal to u plus at, which is equal to 0 is equal to u plus minus 6 into 2. We have u is equal to minus u plus of minus 12. So u is equal to 12 meter per second. This is your initial velocity, which is 12 meter per second, which means the car going at a speed of velocity of 12 meter per second is stopped. So your initial velocity is 12 meter per second. From this we can calculate the distance. From the formula, S is equal to ut plus half at square. So we have u, which is 12, and the time 2 seconds, plus half into acceleration of -6 into t square, which is 4. So what do we have? We have 24 plus of -12, which is 12 meters. So the distance travelled will be 12 meters. This same distance we can also find from the formula 2as is equal to v square minus u square. This formula we used in the previous problems also. So S will be v square minus u square by 2a. So your v square is 0. So u square is 12 square by 2 into -6. So what do we have? Minus 144 by -12. So we have 12 meter. So we get the same answer from both the equations. So with this we are finishing the example problems given in the book. In the next video we will see 5 questions given in page 82 and 83. Thank you for watching the video.